Hello everyone, in this session I'm going to be discussing how you can build resilient Xamarin apps with Couchbase Mobile. I'm Priya Rajgopal, Principal Product Manager for Couchbase Mobile. I'm going to kick things off with a discussion of the tenets of resilient apps. The first and foremost aspect is that apps need to be resilient to network disruptions. So the data that is used to drive your app's business logic is guaranteed to be available irrespective of the state of the network connection. Performance is another key driver. It directly impacts the perceived user experience of your app. For instance, if your app takes too long to download the data to start up because it's downloading data from a remote server, then users are likely going to abandon your app. So users have come to expect that their apps are always responsive and there is guaranteed sub-millisecond response times irrespective of the state of the network. Finally, as apps are used increasingly for storing sensitive data or for dealing with applications that deal with sensitive data, such as finance or healthcare applications, it is important that your apps are resilient to security attacks. This refers to whether an attacker tries to get access to your device remotely or has physical access to your device, so the security of your data at rest. It also refers to security against attacks with attackers who are eavesdropping on the network connectivity and trying to get access to the data. Of course, it also refers to resiliency against rogue clients that are impersonating to be valid clients and trying to gain access to a remote server. Hey everyone. Hi everyone. In this session, I'm going to be discussing how you can build resilient Xamarin apps with Couchbase Mobile. I'm Priya Rajgopal, Principal Product Manager with the Couchbase Mobile platform. I'm going to kick things off. I'm going to kick things off. Hi everyone. In this session, I'm going to be discussing how you can build resilient Xamarin apps with Couchbase Mobile. I'm Priya Rajgopal, Principal Product Manager with Couchbase Mobile. Hi everyone, in this session, I'm going to be discussing how you can build resilient Xamarin apps with Couchbase Mobile. I'm Priya Rajgopal, Principal Product Manager of Couchbase Mobile platform. I'm going to kick things off with a discussion of the tenets of resilient apps. So what makes mobile apps resilient? First and foremost, it is expected that apps are resilient to network disruptions. So the data that drives your app's logic is always available and is guaranteed to be available irrespective of the state of the network connection. The performance of the app or the responsiveness of the app has a direct correlation to the overall user experience of the app. So if your app is taking too long to start up because it's downloading data from a remote server, then users are going to abandon your app. Lastly, security is paramount. So resiliency against network security attacks is important. This is especially true because mobile applications are increasingly used for handling sensitive data, such as finance or healthcare applications. So this refers to the security of the data while it is at rest. It refers to the security of the data while it leaves your device, and it also refers to the access control mechanisms that have to be in place to ensure that a rogue client doesn't try to gain unauthorized access to your backend data store. So what are some typical use cases? Field applications in disconnected environments such as oil rigs, construction sites, mines, disaster recovery areas. In such locations, there is going to be very little or no network connectivity. field team members who are out in the field. They need access to their task list. They're collecting data, doing inspections, and they're recording it on their local device. Eventually, when there is network connectivity, this data that is collected has to be transferred over to their remote database. One important consequence of having multiple users update the data at the same time is that there is a chance for network data for data conflicts. So when two or more writers are updating the data at the same time, there is going to be document conflicts, and it needs to be handled in a way that makes sense for the business application. Another use case is real-time data sync, as it applies to retail stores, theme parks, events where there is network connectivity for most part. But any disruption in network connectivity, even if it is for a few hours, is very detrimental to the business. So consider a retail store which is pulling pricing and catalog information from the servers to the employee tablets. So to consider the case if the store were to lose network connectivity because of an ISP outage. In such a scenario, if the applications are not resilient, then employees would have to turn away customers who are at the store because there is no network or internet connectivity to fulfill the transaction or fulfill the order. So it is important that the data is always available regardless of the state of the network connection. Now, with that context in terms of what is resilient apps as we define it and some of the common use cases, let's look at from a technology perspective what makes apps resilient. First and foremost, it is about bringing storage and compute closer to the edge. So the edge in this case refers to the mobile application. So we are effectively bringing a data store and embedding it within the mobile application so it is always available even if the device is completely offline. So what are some of the characteristics of such a data store? First and foremost, it needs to support the ability to create data, read, update, and delete data, so the fundamental CRUD operations. It also needs to support the ability for extensive querying. So as an application developer, you can build applications and complex workflows within your apps by supporting the ability to locally issue queries against your local database without ever having to leave the device and hit the network. So extensive query capabilities could include full text search, pattern matching, aggregations, analysis of data, and so on. As mobile application developers, you're probably building apps which are reactive in nature. In other words, you don't want your apps to be constantly polling for data in the database, but instead you want to be asynchronously notified anytime there is a change to the data in the database. So having a comprehensive eventing hooks in place is important to ensure that you can build apps that are reactive. And of course, as I mentioned, security is important. So the security of the data while it is stored in your database. So now that we have an idea of or a sense of what it would take to have guaranteed high availability and high low response times, the next question is, what is the database technology? Should we go with a traditional relational style database with tables and columns, or do we want to go with a more NoSQL style database? To be fair, there are several flavors of NoSQL databases, and in my presentation today, I'm going to be talking about document style database. wherein data is stored in the form of either JSON or XML documents. And more specifically, in my presentation, I'm going to be referring to JSON document store, which is really the more popular format, data storage format when it comes to document style databases. So, why would you want to choose NoSQL over SQL? So, for instance, SQL databases such as SQLite. First, for starters, JSON is very popular and is a ubiquitous data exchange format. So if you are building a mobile application, chances are you are already consuming data which is delivered to you through web services in JSON format. And most of the platforms support built-in JSON serialization and deserialization support. So it's very easy to build applications around JSON. Now, one of the things when it comes to SQL style databases is the need for a data model or a schema definition which defines how your data is laid out. When it comes to NoSQL databases, um, there isn't really a structure or a schema that defines how your data is laid out. So it is extremely flexible. So this means your application can evolve as your data requirements changes, and you would not have to worry about expensive data migration. Note that the data migration costs add to the overall startup costs, and that kind of goes against the one of the tenets of uh, resilient apps is that it has to be very responsive. And of course, if you're developing mobile applications, you're probably dealing with objects. And so it is more intuitive if the data is also stored in a format which aligns itself with the way the application uses the data. But if you're using SQLite or some relational style database, then you need to map the objects, that object formats that are used within your application into relational style tables. Now, this causes impedance mismatch. For example, there is no notion of embedded objects in relational databases. You would have to create mapping tables and such. Typically, to get around it, you would have to rely on third-party ORMs. Now, a little bit of primer on a document style database. Think of a JSON document database as one where every document very loosely corresponds to a row in a relational style table. Okay, so this is a very basic view of what a document means. So every row in a relational table would effectively be a document, and every column in the table would be a property within that JSON document. Of course, you have the flexibility being JSON that not all documents need to have all the same set of columns. You can have some documents can have extra columns, for instance. You're not bound by the same number of columns across as you would in the case of a relational style table. And of course, you also have the flexibility of embedding or nesting any number of JSON objects. So it lends itself very well to arrays and so on. So now that we discussed one aspect of the technology that would make apps resilient, which is the ability to store and do compute on data locally within your mobile application, the other aspect is data sync, right? I mean, most of the use cases that we saw is offline first. So of course you need your application to be usable, and you need a way for storing data when there's no network connectivity. But of course, when the network connectivity is resumed, you want that data to be available to all the other connected clients that have authorized access to that data. So the happy part is if you have a document and you synchronize that to the to your server, backend server, through some sort of a synchronization endpoint that gets persisted in your backend data center and subsequently synchronized over to the other clients. This is sort of the basic premise of what data sync is all about. And it's very, very basic. What's shown here is very basic. And as they say, the devil is in the details. So consider the case where one of the applications or one of the devices goes offline. You want the device to continue to be able to make changes to that document. So subsequently, when network connectivity is resumed, that document is synchronized over to this backend server and consequently to all the other clients that have access to that data. So your data sync protocol, it needs to be offline capable. I touched upon conflict resolution briefly when I discussed the field application use case. When you have multiple writers in the system and they're all making concurrent changes to the same data set, you're going to have conflicts. And there needs to be a decision on what is the winning document or the winning revision of the document. So this can happen even if the clients are all online and are making changes at the same time. So it is not necessary that clients have to be offline for conflicts to happen, but it just makes it easier to drive home the point when devices are in fact disconnected. So consider this particular state where you've got a couple of clients. They are all in sync with the backend data server with a particular version of the document. Both of the clients are offline. So client A goes ahead and makes changes to that document. Because it is offline, all these changes are locally persisted on the device. And consider the case where the other device, another client, is also offline. It makes changes to that document and it's locally persisted on that device. Eventually, when network connectivity is restored, both those clients try to synchronize their version of the document with the backend server. But of course, here's a conflict because there are two changes made to the exact same revision of the document. So the system needs to be able to select a winner. And the resolution process might be picking one of the two conflicting revisions, or it might be the case that you might have to merge the contents of the two conflicting revisions to create the winning revision. So conflict resolution is sort of the cornerstone of an effective data synchronization technology. When it comes to security, it's not just about the encryption of the data at rest. It also has to do with the encryption of the data in motion, in transit, right? And of course, it also has to do with enforcement of access control policies to ensure that only authorized clients have access to the data, and you want to prevent any unauthorized access to data. So consider this case where there are two clients, connected clients, and all of them have read access to this data. But let's just say that a particular client has only read-only access and doesn't have write access to the data. So any attempts by one of the clients, by the client that doesn't have write access, should be blocked by the system. So this is enforced through effective access control policies that ensures that only authorized users are allowed to write or update data. When it comes to data routing, you want to have the flexibility to decide whether a document gets routed to a particular user or not. So even if you have a major backend data store, you don't want to duplicate or synchronize that entire data set over to all the clients. It would be, there might be some data, a subset of data that is shared or common across all clients, but it's very likely the case that each client has their own private set of documents. So your data, you need to have a effective data routing mechanism in place that will ensure that only that the right set of documents or the right subset of documents reach the right set of clients. Of course, this is not just for data that is getting propagated from the backend servers to the clients. That this also has to do with updates coming in from the client side. So now that we have somewhat of an understanding of what resilient, what makes apps, mobile apps resilient, and some of the technology that would be required to enable that, I'd like to give you a brief overview of Couchbase Mobile. So Couchbase Mobile platform, it consists of three main components. It includes the Couchbase server, which is the highly scalable and highly available NoSQL database server. It's the NoSQL document, and it's both a document as well as the key value data store. You can deploy it on any public cloud environments. You can deploy it on, you can containerize it. It's cloud native ready. You can deploy it even on your own laptop for development purposes. And in fact, for my demo today, I'm going to have this entire stack, the Couchbase server, deployed on my local machine. On the far end, taking the power of Couchbase server's NoSQL data platform all the way to the edge is Couchbase Lite. Couchbase Lite is the lightweight embedded NoSQL database. It includes full CRUD and query functionality. It's a full-fledged data platform. The ability to synchronize between Couchbase Lite is enable clients, and the backend data store is Sync Gateway. Sync Gateway is sort of the middle tier. It is the secure web gateway. It's responsible for data synchronization, access control, and data and authorization. It is stateless. It doesn't persist any data. It is effectively what the name indicates, a synchronization gateway. So the data that is routed by the sync gateway is either persisted in Couchbase server in the backend or in Couchbase Lite enabled clients. And of course, everything is secured end-to-end with AES of 256 encryption for data at rest, and everything is protected over TLS. So a little bit more about Couchbase Lite. Couchbase Lite is the embedded database. It is available on all the popular mobile platforms, but as you can see, it is also available on for use in desktop environments. We have a Couchbase Labs project which exposes C API bindings. We've got a .NET platform, allows you to build applications for the desktop environments, and we've got Java support coming soon. Of course, in today's discussion, I'm going to be focusing on Couchbase Lite for Xamarin. So for the rest of my talk, I'm going to be going through the demo application, and I'm going to sort of weave in and out of describing Couchbase mobile concepts and showing the demo code. So hopefully it's not going to be too confusing and you can follow along. So the app that we're going to be using for the demo is a Xamarin's Forms app, and it is built using the model view model architecture pattern. Note that as a database, Couchbase Lite does not mandate a particular architecture pattern. You're free to choose MVC, MVP, or whatever else fits your application needs. For the purposes of the demo, we are using an MVVM architecture pattern because it works very well with .NET and Xamarin apps. So in a little bit of a primer on what MVVM is about, it includes the view layer, which is the layout, the UI layer, which is the XAML forms, right? The layout of the buttons and the text boxes and so on. The view model is where the app logic resides. It binds to the view layer and is responsible for accepting all the input from the view layer. And it is responsible for updating the corresponding model layer, the model or the data layer. Anytime there is changes to the data, the model layer sends notifications to the view model, which in turn sends notifications or updates the view. So the key thing to notice, as is the case with typical architecture patterns such as MVVM, is the separation of concerns. So each of these layers, view, view model, and model, can evolve independently of each other. Another data access pattern that we're going to be using in our Xamarin application is the repository pattern. This is a pretty popular pattern when you are trying to access data from a persistent store or from any data store. So your app logic, which resides in the model view layer, um, interacts with the repository classes, which in turn interfaces with the Couchbase Lite database. The repository classes are responsible for data mapping between the data that is retrieved from Couchbase Lite and mapping it into the native objects that your application uses. It is also responsible for queries. Now here's the data model that we're going to be using within our application. It is really very straightforward. Again, if you remember what I discussed when I discussed JSON document store, I mentioned that every, if you want to sort of contrast it with or compare it with SQL style databases, every row would roughly correspond to a document. So in this case, I've got two types of documents. One is the user profile document, another one is a university document. Notice that I have included, there's a type identifier which defines the type of document. This is not required or it is not mandated by any schema, because the NoSQL data store is schemaless. But it is recommended practice that you define some sort of a namespace or a type identifier that serves to logically group the documents of a particular type. So if your database is dealing with multiple universities, and each university has got a corresponding university document, then it would make just sense to sort of logically group all those university documents using the university type identifier. The other thing to note is that the user profile document is the document that we will be creating and modifying from within our application. The university document, on the other hand, is static, as in this is pre-built and pre-bundled with the application, and we just query against against these documents. So this is something that is unique and important to note, is that you can have multiple instances of Couchbase Lite embedded within your application. Now, for most practical purposes, you really don't need more than one or maybe two, but then if your application needs that kind of physical separation of data, you can achieve that with multiple instances of Couchbase Lite. One common pattern for having one common pattern for having multiple, or not pattern, one common use case rather for having multiple Couchbase Lite instances is the need to separate your static pre-bundled public data from the dynamic data that you want to synchronize with your backend data source. So in this particular application, I'm going to pre-bundle my university database with my mobile application. And the university database consists of all these university documents. And all the user profile documents are created and stored in a separate user profile database. So my demo is going to be split into two parts. The first part, I'm going to be only showcasing the offline only capabilities. Here we're going to use Couchbase Lite as a NoSQL local store in standalone mode. We'll demonstrate the common database CRUD operations as well as some basic querying capabilities. And also we'll be demonstrating the concept of a pre-built or a pre-bundled database that you can load along with your mobile application. So zoom this in. So everything that I am going to demonstrate today is available on GitHub, and you can find resources to or links to the same in the resources section of this presentation. So I'm going to first launch my simulator with my iOS version of the app. As you can see, this Xamarin app includes an iOS version and Android as well as a UWP version. And of course, since I'm running on my Mac, it doesn't allow me the option of running a UWP application. So I'm going to launch a iOS simulator with the app. And so while that's coming up, you can see on the left hand side in the project explorer that we use the MVVM Platon. You can also see that we have the university's database embedded within the mobile application. So this is the universities.cvlite2 is the Couchbase Lite database file that we have embedded within the application. And this, again, as a reminder, is the database that hosts the university documents that you're going to query against. So I'm going to log in as a user. I'll give you a little more context about these users later on. But for now, you can see that there's really nothing related to the user. The first thing I'm going to do is add some details. Um, okay, so to prove that this data is when I created this user profile, it creates a corresponding user profile document and persists it locally in the Xamarin data in the Couchbase Lite database. So now I'm going to terminate the app. I'm stopping the debugger, and I'm going to launch the app again. So it's a brand new launch of the app. I'm going to log in as the same user, and you can see that it's picked up the data that was previously persisted in the local store. So let's quickly go through the code and see what's going on behind the scenes. The key thing, I'm not going to be diving into the details of the model view and the view because most of, what Couchbase Lite does, being a database layer, it resides in the model and the repository classes. The repository classes are where you define your interaction with the model layer. So first is the database manager that you can see here. Let me zoom it in so it's a little more visible. As you can see, there are two databases that we deal with within the application. First is the user profile database. Creating a new database is really simple. It's just a new command. You provide it with the name of the database and some configuration options. For example, the encryption key. If you want to support encryption, you would specify the path where the database file is to be located, the log path, and so on. The second database that we're using within our application is the universities database. As I mentioned, this particular database is pre-bundled, right? If you go back to the iOS, you see that the universities database is pre-bundled with the application. So now you can copy this database and use that. So you create a new instance of the database using the database that was pre-bundled or bundled with your mobile application. So that is all it takes to create a database, is just a single line. So very, very straightforward, and you can create as many instances as your application needs, demand. The second thing is the user profile repository. So this is the repository class that deals with the actual creation of the user profile document, updating the user profile document, and so on. So very quickly, saving the document. Saving a document or creating a document, very simple. You create a mutable copy of the document. We have a set of um, type setters and getters, which makes sure that you don't run into any issues or any issues are caught early on during compile phase rather than during runtime. The other thing to note is that we also, in addition to the standard JSON types, we also support blob data types. So you can store or persist any binary data in your Couchbase Lite document. So saving a document to a database is a pretty straightforward document.save operation. Retrieving a document is simple. You would just do database.getDocument and provide it with the document ID. And once you have access to the document, you can have access to the various properties in the document. Let's take a quick look at the university repository class. This is the repository class which is responsible for querying the university database to fetch the list of universities. So if you remember the application, when I clicked on, when I entered the location in the search bar and clicked on lookup, the list of universities documents that are returned back, or the list of universities that are returned back, it is the result of a query that is done against the university's database. The query, as you can see, is pretty straightforward, and similar to has got a SQL-based syntax, right? And so you have select from where. So if you come from a SQLite world, this should feel second nature to you. As you can see, the benefits of a query builder class is that it enforces compile time checks, allows you to, it gives you options on what you can do next. So for example, I would want to, here are my other options. I want to limit expression dot int. So in this particular case, I want to limit the number of results to just one. So I'm going to save this and rerun the application with this change. So if you were using, if you were passing in raw strings in SQLite, for instance, if you make an error, right, that would likely be caught only during runtime. But using a query builder API, which has got a fluent design pattern, it makes sure that any errors are caught upfront during, or to the extent possible, are caught upfront during compile time. So here, going back, and I'm going to do the same search, because we know that New York, when we searched for universities in New York, it returned more than one. And now you see that it returns just one university. So it's pretty straightforward to implement querying, and I've just scratched the surface in terms of what's possible with our querying API. Anything that you could possibly think of as far as querying a database is available. You can do string matching, pattern matching, regex operations, arithmetic operations, aggregations, full text search, joins, null property checks. So it's extremely comprehensive. So now let's kind of switch back to the slides for a little bit as we move to the second part of our session here. In this part of the demo, we are going to be talking, or we're going to be presenting bidirectional data sync between Couchbase Lite clients and the server. We are also going to be looking at data access control and validation in the sync gateway. So in order to enable that, we need the Couchbase server, which is the persistent data store, the backend, and we need the sync gateway. The sync gateway is effectively, think of the sync gateway as another client from the perspective of Couchbase Server. Now, Couchbase Server does support a large number of SDKs for popular languages. So if you are building a backend client, right, not a front-end client, but if you're building a backend client such as a Go or a PHP or a Java client, you can use one of our backend SDKs to build those clients, and those clients will directly interface with the Couchbase server. Now, think of Sync Gateway as another client of Couchbase Server, and it supports data synchronization. At the same time, Sync Gateway also exposes a REST endpoint, which is suitable for web front-end clients. Some of the other things to bear in mind is the Sync Gateway during startup or during launch, you provide the Sync Gateway with a configuration file. This configuration determines the runtime behavior of the Sync Gateway. We'll look into the configuration file in a second. But the key thing that we are going to do in the next step is first launch Couchbase Server, and second, set up the Couchbase Server so the Sync Gateway has access to it. And then third, we are going to launch the Sync Gateway itself. So switching back to my terminal here. Again, I'm going to zoom it in a little bit. So the first thing is I'm going to launch my Couchbase server, and I'm going to do that. I have a launch script here for convenience, and this starts up a Couchbase server. So very quickly, what does this script contain? It is a simple Docker run command, a standard run command. I'm going to run Couchbase server. I'm going to give it a name cb-server, and these are some of the standard ports that need to be exposed or are in use by Couchbase server. And this is the Docker image that's pulled from Docker Hub. This is nothing special here. So standard Docker command. Now I'm going to go and try to launch and set up Couchbase server. This is a vanilla Docker image available from Docker Hub. So I'm going to start a new cluster, and you can see that it's really straightforward to do this, and it takes a few seconds to get going. And so that is it. So the next thing is to create a bucket. A bucket is sort of analogous to a database. So I'm going to add a bucket where I'm going to persist all my data. I'm going to call it user profile because that's sort of the application. The next thing, if you remember, I mentioned that the Sync Gateway needs to be able to access and talk to Couchbase server. So in order to do that, we need to create an RBAC user corresponding to the Sync Gateway. So I'm going to create a user. And I am going to give it application level access to the bucket. So now I've created the user successfully. So the next thing that needs to be done, so that is it. That's all that is to run Couchbase server. And as I mentioned, you have the flexibility in terms of where your Couchbase server can be deployed. You can deploy it in a cloud, public cloud, in a private cloud, on-prem, or on your device for development testing purposes. So next thing I'm going to do is launch my Sync Gateway. Again, I've got another script to simplify this process, and we'll take a look at what the script does. So as you can see, this is another standard Docker command. I'm running the Sync Gateway container. I'm using the standard Sync Gateway image of Docker Hub, and I am launching it with a config file. So let's quickly take a look at the config file. So there are a whole bunch of configurable options. Most of them, you have defaults if you don't specify any, but there are a lot of them that you can override the defaults. They're all specified in the documentation. But let's look at some key ones here. So the first and foremost is the bucket, the name of the bucket. As if you recall, where on the Couchbase server, I created a bucket with the name user profile. So I have to make sure that the bucket name that is specified in the configuration file corresponds to the bucket on Couchbase server. The other thing I have to do is point it to my Couchbase server. So I launched the Docker container and I gave it the name cb-server. So I'm going to point it to that. In an actual production environment, you probably want to configure TLS. So you have a secure connection between Sync Gateway and Couchbase server. The other key thing to note is the username and password. This corresponds to the RBAC credentials that we previously configured on Couchbase server. Okay, so very quickly, if you go back to Couchbase server and you looked at thing, it corresponds to these credentials. Of course, you have the option of using X509 certificates if that's deemed more secure. In addition, so this again is the credentials with which your Sync gateway talks to Couchbase server. In addition, note that we have pre-configured a set of users statically within the system. Now, in a real application, you're probably not going to be doing that. Users are probably going to be created dynamically. So we have a REST endpoint on Sync Gateway through which you would be creating these users. But for purposes of this demo, I have pre-configured or hard-coded the set of users that can be supported in the system. So if you remember in my application, I used user 2. So that is a user that's valid in the system. So which means when this user gains access to the system, they should be authorized to synchronize sync data with the server backend. Okay, so this is what the channels does. It tells that they have access to all the channels in the system, and we'll talk about channels a little later. So now let's confirm that the Sync gateway is running. Okay, it looks like things are good. The other way to verify that the Sync gateway is running is to just open up port 4984. You see that it is in fact running. Okay. So now let's go back to our application. I'm going to switch over to my sync branch. Oh, sorry, wrong command. Oh, that was because I made those changes here. Now going back, reload this. So I'm going to launch this app again, and then we'll look at the code and what's going on behind the scenes in a second. So the key thing that's happening in this app is that in addition to what it was already doing is that it is now set up to replicate or synchronize data with a remote sync gateway. I'm going to go here, just make sure that that's the case. So as you can see, I have a remote sync URL, and this is what it is set up to replicate to. So I'm going to create again a user profile document. Remember, this is a brand new application. So you're going to have to go through the exercise again of creating this document. Okay, I'm going to save it. Okay, so the next thing, let's go back to the Couchbase server and see what's going on there. So if you look at the documents, you will see that there's a new document corresponding to this user, and it is the content. It includes image data, includes the data type. So in order to um, show you, prove to you that it is in fact the same document, I am going to update this document, and I'm updating it directly on Couchbase server. And I'm going to save this, and you can see that the document is synchronized over to the Couchbase Lite enabled client. Now, I'm going to stop this, and I am going to bring up another client, a Couchbase Lite, a Xamarin Android client. So, and this takes a bit of time for the emulator to come up. So in the meantime, I'm going to log into my iOS app with this user, and I'm going to spend some time going over the code. So as I mentioned, the only thing that has changed really between this version of the document, the sync version, sorry, of the application, and the previous version of the application is that it now includes replication. Oops, I just noticed that I made a mistake here. I'm going to stop this, because if you're running something on the emulator, you need to give it the remote endpoint has to be 10.0.2.2. I can't use localhost for the Android emulator. So once this gets a chance to stop, I'm going to update the URI. So the localhost works when you are working with the iOS simulator, but then when you switch to the Android emulator, I have to use 10.0.2.2. So with that change in place, I'm going to relaunch the emulator with the app. So let's very quickly look into what is done in order to enable the replication. As you can see, it is pretty straightforward, and is just less than 10 lines of code. You specify the target URL endpoint, which is the sync gateway endpoint. Provided with a set of configurable options. You can specify if you want it to be push and pull, bi-directional. You can specify if it has to be unidirectional push or either pull. You also specify if it needs to be continuous mode. And then this is the authentication. We are using basic auth, and we are specifying the username and password. Credentials are provided here. We also support OAuth or custom authentication with any custom auth provider. So once you configure the replicator with the specified configuration, you can optionally add a change listener. So anytime there are changes to the status of the replication, you will be notified, and then you can start the replicator. So it's really just that. That's the only code change that is required between this version and the previous version of this app, is those 10 lines of code to enable synchronization. So now that I have both my Android and version of the Android and iOS version of the app running, I am going to log in as the same user. So this is going to effectively connect back to the sync gateway to Couchbase server. And of course, it's running in debug mode. It's the emulator. It's pretty slow, but it is fetching the data, and it's getting updated. So we can also, for example, let's just say Main Street, and if I save it, you'll see that it's getting pulled back here as well. So effectively, you can have any number of clients, and with Xamarin, of course, bringing a cross-platform technology, you can build both iOS, Android, and in this particular demo app, sample app that we have, it also supports UWP applications, so you can synchronize data between your iOS, Android, and Windows clients using Xamarin. So that was the demo. Well, there's one more thing I'd like to kind of show you, just to I'm going to log off, and user 3 is also a valid user in the system. I'm going to log in, and as you can see, it doesn't synchronize the data corresponding to user 2. So users 2 data is specific to is only delivered to user 2, and user 3 is not presented with the data corresponding to user 2. So it's not synchronizing. The synchronization protocol doesn't allow, its synchronization configuration does not allow that. So let's go back to slides so we can look at some of the concepts here. Going back into presentation mode, um, we saw that the sync gateway, it synchronizes data and the REST API. So the concept of channels. Channels is a combination of a tag and a message queue. The purpose of a sync gateway channel is it identifies the type, purpose, and accessibility of a document. So it's a way to partition your data set. So in this particular application, you can have user one's document in user one's own private channel, users two document in users two private channel. If there are a set of documents that are shared among users, you can put that in a shared data channel. Now, the assignment of documents to channels can be done statically. You can define that when you're creating the document through a special channels property, or you can use the channel API within the sync function. So if you haven't noticed, within our configuration file, right, the JSON configuration file which we used for launching the sync gateway, it includes a JavaScript function. This JavaScript function is, we've extended the JavaScript library to include a set of APIs. So this is the function where you define your dynamic access control policies. So every document, every write that is processed by, every write and read, but every write that is processed by the sync gateway is processed by the sync function if one exists, and suitable access control policies are enforced at the time. So the other thing, use of channels, is that you can minimize the amount of data that is synchronized to the devices. So even if a user one has access to, say, channels A, B, and C, you can specify that, at the time of replication, a user one can specify that I'm only interested in channels A and B. So I'm going to leave this session with this slide. And of course, if you have any questions, you can reach out to me and by email or via my Twitter account at RAJAGP. Again, thanks for listening.